Hello everyone, this is Arwin. Uh, I'm back, and today I'm gonna have a hangout talking about gravity. Gravity is a highly debated subject, although to most people they're pretty set in how they view gravity, and even among flat earthers. And I've noticed that there's just this general misconception about what is gravity really, because well, we all know that globe believers firmly believe in gravity. We've all seen uh, Neil deGrasse Tyson drop the mic, and this proves gravity to them basically. But globers, all of them, they automatically assume that this means that gravity is a force that is caused by objects being pulled towards a heavier mass. And this is wrong. And I already talked about this in the previous Hangouts because there is no real measurable force there. There have been some like theoretical scientists that even worked on experiments, and they say, yeah, gravitational waves and everything, and this has been proven. It proves that there is some type of measurable gravity. But this is pure fiction because gravity has always been on this earth. It has always been a constant. And besides this constant, there's no real way to measure it. It's not like a regular force like magnetics or electricity where you can measure these physical attributes, these fields or these variations in the force, which make it very tangible. Uh, Gravity is more a mysterious force that has always accompanied all of known creation. Like ever since humanity was there has been this constant direction, basically called down, and objects fall down. Like this is how we look at things. We are basically mostly solid objects, people, living solid entities, and we are standing on our feet. And this is because the gravity determines that this way is down and that is up. But that's still really a personalized perspective, because what it mostly does is it determines the factors of buoyancy and density, how they actually interact with their environment. Because without any gravity, and I'm not talking about gravitational pull, I'm just talking about gravity, without it, things would not fall in any direction. Things would not separate. Lighter matter with less density would not separate itself from heavier objects that had more density. And it is gravity that actually makes this possible. Gravity is basically a given that matter separates itself through uh, its relative density and orders itself. Uh, it orders basically that heavier objects go down and lighter objects go up in relation to their surrounding. And this is what gravity really is. It's a constant. It's a constant that determines, and this is widely measured. This is just a given. You can't argue that this is true because it's been a very widely repeated experiment. All objects, fall down at a constant velocity of 9.8 meters a second. And this constant, uh, it's of course there are other factors like there's air resistance or water resist. There's resistance of matter that basically slows down this falling motion. But If you would, in an experiment, uh, like in a vacuum drawn tube, you would let two objects fall in a perfect vacuum, no matter their density, like a feather and a rock, they would both fall down at the same speed. And this also, I've seen this experiment uh, displayed to me in physics class when I was young. This is just a given. But there is no measurable explanation what force is actually calling this. It's just a constant thing. It's there and it's equal everywhere. There's no location on the earth where there's actually where experiments have been done like this, where it proved that the falling uh, speed would be different. It's only theoretically experimented. Like, for example, on the moon, they would say, yeah, gravity is lower here, so things drop at a different speed, and there's you can jump higher. And but we all know by now that the moon landings have never happened. It's not a real physical object out there. So all of those types of experiments that prove that gravity is different in different regions, these are all false. These are all based upon illusions and trickery. Because on the Earth, gravity is always a constant. It's always the same falling ratio, and it's always the same. It's a given, and there is no real, direct, repeatable way to measure it except by these measured constants of matter itself. It can only be measured through matter by seeing how matter responds to actions and then calculating backwards in what this falling constant is. And that is how gravity has originally been determined. But it is still to this day a mystery as to what actually causes this. And I know that in the last 2 years, especially, there's a lot of flat earthers that have been debating, like, yeah, but it's that gravitational pull, then what is it? What could have caused it? And there are all these theories about that. It could be electrostatic energy, that there might be an electric field that, like static electricity, which is actually measurable. You can directly measure static electricity. It's like a field, and it can pull things over a reasonable distance, not too far away. Depends on how big the object is. It can pull things towards it through static electricity. And this is different because static electricity responds differently at different distances. So even if gravity was actually a misunderstood static electricity on this earth, then there would be variation measured in the falling speed of objects. And this is never the case. These laws, it's like gravity, this constant is always the same everywhere, even in the really high altitude atmosphere. It's always been the same. And there's only theories about about going into orbit and going in outer space, and this is all NASA doing. Because even with our balloons, when you send them up there, they don't stay up there forever. They never do. They always like deteriorate or they burst because of the lack of air pressure comparative to the pressure inside of the balloon. And then the whole thing falls down again at that constant speed, 9.8 meters a second minus air friction, which should be less in the higher atmosphere. Like things should relatively fall faster or accelerate faster to that constant speed of 9.8 meters a second because the air is less dense up there. But still, that falling speed is always the same. So it's just everywhere. It's like the ether. It's a field that's overlaid on our entire physical reality, and it's just there. And I know that all the people in the world, we have this tendency that we want to explain things and we want to understand it and we want this certainty of what it is. But we are not shy of jumping the gun like jumping to conclusions. And ever since, well, Newton started the whole gravitational pull, and Einstein and everyone like jumped in. Ever since then, there has been a explanation as to what causes gravity. And people find this a very comfortable idea, but it's not real. And because we are now, throughout generations, used to having this explanation for what gravity really is, that it's a force that has an explanation as to why it's there, it's very hard to take a step back. It's very hard to actually be honest and realize, like, no, we can measure gravity. We have this constant that we've determined throughout all of human history, but we still don't know what it actually is. And especially because of this mysterious constant element about it, that it's everywhere the same. If there was some kind of variety in its strength, then we would have some tangible thing to go on. But at this point, I can even, uh, with, well, not with absolute certainty, but I could even like declare that as the heavens are fifth dimensional, at the edge of our vision, always spinning around our flat plane from everyone's perspective, that gravity too could be a fifth dimensional force, which the nature of it, it's just constant everywhere, and we can't determine where it's coming from so far. So there might be an explanation in the fifth dimension as to maybe it's not constant over there. Maybe like the heavenly bodies could theoretically be physical bodies in the fifth dimension and they're not over here. Maybe gravity is also varying within this fifth dimension. And on this earth, it's just constant everywhere. You can't escape it. In the physical world, you can't escape it. And I thought, well, this was a very worthy subject to start talking about, because no matter where I go, like flat earthers, they try to tell me like, no, no, it's gravity doesn't exist. It's all buoyancy. It's all density. But yeah, that still doesn't work without a gravity, without a constant that separates the heavy from the non-heavy. It doesn't work without gravity. And it does not explain this constant of what gravity really is. So it's like I'm stuck in between the flat earthers and the globers now, and they're both disagreeing with me, and they both have their own explanations as to what it is, and they're both wrong. It's you can't deny that there is this constant force, although calling it a force is even wrong, because a force is is like energy. You can always trace back where it comes from. It's measurable, it's varying usually. And gravity is not. It's everywhere. It's just a constant force, a given. And that's it. That's just it. It's I guess it's very frustrating to a lot of people, but that's just what it is. And you can't really debate that it is a constant, that it's measured everywhere. It's used throughout all of physics. Throughout all of earthly physics, it's always used as a constant, especially with mechanics. It's very widely applied. And yeah, so I wanted to talk about that. I'm gonna look in chat now, see who's there. Thank you for coming, all of you. See the Oh, I see the Globers have caught on. They joined me as well, so they're now going to constantly spout out their scientism garbage, basically, showing all these theoretical experiments and how that proves everything. But yeah, it's not going to work. You can like you can repeat all those textbook things like to infinity. It doesn't make it real just because it's written down somewhere. So sorry about that. I'm not even going to go into a debate about it. Like I can bring up the experiment again, that how to disprove it, because the Cavendish experiment is a mess. It's very easily to distort it. It's very easily manipulated. It's almost always used with metal objects that are susceptible to electromagnetic interference. So you can't really measure gravity, and there is nothing really that you can do to prove it other than things falling down towards that one direction we call down. And there might be an experiment that we could actually do to prove that there is some kind of gravitational pull, which would be taking two objects. I've talked about this many, many times. Take two objects, non uh, like stone or something else that's not very electrostatically influenceable, doesn't cause electrostatic energy, that's not metal, that cannot be influenced by magnetics. You take two objects, very close proximity, and you drop them in a very long vacuum tube. And as they fall, they are basically suspended, and they will remain exactly at the same position in relation to each other, because in a vacuum things fall at exactly the same speed, 9.8 meters a second. And if these objects would be dropped and there was a gravitational pull that would cause one large mass to be pulled, even though we can't measure it, towards another large mass, then at the bottom, when it's fallen down, these objects should be closer towards one another. And they're probably not, because if they would be, it would be the number one proof of gravitational pull that everyone could experiment, repeat the experiment, and it would solve basically that ancient concept, and it would give like the Globers a huge weapon against flat Earth and against all of that stuff. So it doesn't work. It's otherwise, yeah. I will try to at some point see if I can get somebody to actually set up this experiment to prove it, and if possible, even like measure it with lasers to really see if objects do get closer and how much it might be insignificant. There might be some insignificant pull, and even then, if there was an insignificant pull, that would still be some pull. But I doubt it was. I doubt it would work, because otherwise the scientism textbooks would be full of it. It would be an experiment that just proved it. And it's not. We just got this weird Cavendish experiment that takes a lot of time, uses like electromagnetically influenceable objects, and it's very easy to tamper with. Very, very easy to do this. And I think it has been a lot. And besides, as long as you're going to use metal objects, they're going to be prone to any magnetic interference, and you can't really, even if you put it all in a Faraday cage, that that still wouldn't matter, because there's like, even though they might be sealed off from outside electrical interference, inside they can still be interfered with. Even running electricity or anything like could cause some pull other than of this theoretical gravitational pull. So I don't go with the Cavendish experiment. It's a typical scientism gadget that's been devised as a very steampunkish style experiment from the Renaissance age to fool us into believing there's such a thing as gravitational pull. And there's not. There's just gravity, the constant of 9.8 meters a second falling speed of all objects towards down. And that's it. That's all there is. So let's get into chat. I see Knowledge Cavender is here, and he makes a very good point. Math is not proof. Math is indeed math. If you measure something, you measure something, then you have proof. You have proof of this experiment setup and that it works that way. And if other people can repeat it, then it's proof. But it doesn't prove the nature of it. It doesn't automatically prove what causes it. That is something else. And besides the constant falling speed, there's nothing else you can measure gravity by. It's non-measurable. There's no force that has any variation that can prove gravity. Really, it's only the given, the constant of the fall. That's it. And check back. I see Ron Burgundy, and he says there are other experiments that prove otherwise. I highly, highly doubt that. Uh, see, Nick L has joined me. Multi Tom Tom, and then Winfield. Always good to have you here, man. Good to see you're more active these days. Uh, Derek Nelson. Good to see you. Mark Taylor. Let's see who else is there. Peanuts Clark. So I think I got a lot of Globers in here, and that's fine. You all want to get it off your chest. You all believe in gravitational pull, and you've learned a pretty complex piece of mathematical equations and data, and yeah, you want to apply your knowledge because this knowledge that you've gathered made you feel like you were smart, like you were worthy. But yeah, I'm sorry, but you've been duped. It's like reading, well, it's like reading a Bible. Not that I'm saying that the Bible is wrong, but as most atheists approach the Bible, it's like, yeah, scientism is the same. You get to learn stuff and with explanations and everything, but it's wrong. There are just falsehoods in there. And because you learned this and you're attaching this self-worth and this intellectual status to it, it's very sad because it's keeping you a prison in that data. You're clinging on to something that's just wrong and you need to snap out of it because yeah, you're never going to be proven right, no matter how many times you repeat it, no matter how much ridicule you put over the other party that denies what you know to be true in your vision. It's not going to happen because yeah, the earth is flat. There's no curvature, there's no measured curvature. The only apparent curvature that has ever been measured is always away from you. It's never to the sides, and there's no constant in it. And there needs to be an absolute constant to declare the Earth into a globe. There can be no variation in this. It's just, it has to be one exact curve or everything's wrong. Even like the heavenly bodies, all of that just wouldn't work out. So yeah, I don't know. Most of you have heard endless arguments about the flat Earth, and if you refuse to let this sink in, then it's not gonna happen. I'm not gonna convince you. Yeah, no, no, curved water. No, I don't lie, and I appreciate it if you stop talking that type of BS. I'm talking the truth here. This is all just very logical sense. Gravity exists, gravitational pull does not. It cannot be proven. Gravity is there, however. So it's just there. And it's a mystery. And I think that the Freemasons, they like to use the G, not not even because it is, well, with the theory of gravity and the gravitational pull, it's not, it's like it's a two-layer thing. Like the foundation or much proof of the globe Earth is based upon this gravitational pull, but at the same time gravity is one of the most mysterious constant forces that exist. And I think the Freemasons recognize this. Like it's there. It's like a measuring tool. It's amazing, but they know that they don't really understand. So it's like a mystery force to them. And I'll bet you there have been probably hundreds of people that try to look beyond the gravitational pull and really try to figure out what gravity is. And they probably all failed because, yeah, how there's only one way to measure it, and that is how by the constant speed of things falling down, and that's the only way. There's no other force that directly coincides with the constant of gravity. It's not there. Or if it's there, we cannot measure it. We cannot stably measure it and draw any real sensible conclusions of it that people can repeat in experiments. Maybe we will. I don't know. If theoretically, if like certain conditions could be created, but I have no idea how they would do it. Like some kind of electromagnetic process that could make a natural gravityless place. So it's not like objects would not be pushed or pulled by magnetics, but like gravity could be cancelled out somehow. Then that would be a big help into trying to understand at least what gravity is, and maybe it can be done, and that would be a giant breakthrough and actually create literal gravityless environment somehow. That would be amazing. But at this point, it's still not there. It's just not there. So I think I almost already said almost everything that I wanted to say already. Uh, I'm open to questions as long as they're not based on false assumptions. If you want me to explain more as to what I'm talking about, I've got a very elaborate content for what I'm supposed to be talking about, what I wanted to talk about in this hangout in the description, so you can always read back. Oh God, Nick L, I don't know you. I'm not willing to just let you on and do your globe rambling stuff, because you can tell me all the experiments that have proven gravitational forces out there, so-called in instances, and but it's not real. I know these are lies. So I'm not interested in the depths of your knowledge of scientism. I want to explore this literal concept, like what is gravity, why is it there, and how does it work? How does it work with the law of buoyancy? Yes, Steve Thornton. I like the way you said that. It says it's called buoyancy force, which is a result of gravity. Yes, that is basically what I'm trying to say. Buoyancy, without gravity, it wouldn't work. Things would not separate. The heavier would not go into this direction called down, and the lighter would not go up without it. Things would just float in their place. There would be no shift without gravity. That is what it is. Law of buoyancy is how much is explained, the workings of this world, how things to look and react the way that they are. But without gravity, it would all just float in place. There would be nothing. It wouldn't really work the way it does. It's law of buoyancy is a result of gravity, of the constant of gravity. But gravitational pull really has nothing to do with it. So you don't need gravitational pull to make the law of buoyancy work. what I'm trying to do here, curved water, is I'm trying to talk about the concept of gravity and the misunderstanding within flat Earth and among globers especially. Like, I'm trying to explain in basic physics what it is and how we came to it. That's just it. It's very basic. It's not a very elaborate subject even. It's just people assume that either gravity is some kind of force that's caused gravitational pull, or they say no, it doesn't exist. It's not there. It's something else. But it is there. It's a constant and it's just there, and that's it. And we can only measure it by how matter responds in this world. There's no field that we can detect that actually does cause it. We can't repeat that. It does work. It does work. It's a given. And it does work because everybody can do experiments to prove it, to prove the constant of gravity. So it is. It's just a given. It's just an unexplained given. You don't know why it works like that, but it does. And there's no change in it. And this non-changing element is the most telling. That it is a constant. That's just it. So deny its action. What do you mean, curved water? What am I denying? What action am I denying? No, story now. There is no field. There isn't. There's, well, like a field, it could be measured. Like if there was really a field, then it could be measured. But it's just a constant. It's just there. It could be like a field, like the ether, like I said. But it's everywhere and it's not a local phenomenon. So that's why I call it a constant, because it's a given, it's there. That's just the way it is. And until we get more insight as to what does actually cause gravity, then we could talk about the mechanics of it and what would actually how it works, what it really is. But at this point, it's just not there. We don't have this knowledge. It's not public anyway. There might be weird experiments done with gravity that we never get to hear about because they don't want to share it with us. But as far as we all know, we just get to get told the classical gravitational pull story, and that's it. That's the only thing that they can tell about it. And if you go into discussions about that, you'll get to hear all the experiments, but nobody can even then really explain why and because science, exactly. No, Ron Burgundy, the theory of general relativity, I know it's very well explained, but it's incorrect because it doesn't account for the ether, which is there. And experiments with light have proven this. Because light does actually slow down to a constant as well. What is the force of density? Hmm. Uh, the, well, that's the thing. That this is what a lot of flat earthers say. What they say that gravity is density, but basically, what density is just the difference between where rate the weight volume ratio of matter. That's it. But without gravity, it wouldn't do anything except be more dense or less dense. Gravity is which is the element that actually makes it separate, makes the less dense objects go upwards in relation to the heavier objects. That's it. Um, Mathematics it has barely anything to do with all of this. Like you could, like the acceleration formula, which is applied often with gravity, that is a mathematical thing, and that's very useful. It's very measurable. Everyone can repeat that. That's a good thing. And I'm not too great with math in the sense that I'm very good at visualizing things. I'm not very good at learning formulas. I I'm more of a like I like tangible things and visual things. And the whole formula stuff, it gets convoluted and you lose track. You lose track of what is tangible. And this is a general problem with a lot of mathematicians and with a lot of globers. You stick to theory, you stick to math, and you just say, hey, it works out in the math, so it has to be like that in reality. And it's just not the way it works, really. It's an illusion. Math can prove reality, but it can also prove things that are not part of reality at all, that are just theoretical. So, wow. I've never seen such a globe riddled chat room. It's incredible. It's like you all lined up just to pour out your dissatisfaction with my denying of the gravitational pull, haven't you? You just couldn't help it. And I see that I don't see many others. They're like sticking to the background or something. Are there any flat earthers in here? Speak out, please. Please let me know you're also watching it. It's very tiresome just to be talking to globers because then I constantly have to address them. And I would rather help you guys that really know the earth is flat to understand the concept of gravity better because it's still there. It's just not a gravitational pull. Hello, Didi. Good to see there's some flat earthers in there. Derek Nelson, also a flat earther. Indeed, the earth is flat and it's not moving, it's stationary. Very good. Road FFM, good to see you. That's funny. No Story Now says it's like a big flat button magnet. That's hilarious. But despite there is some kind of there is a magnetic field, obviously, but magnetism doesn't influence all matter. It just influences certain matter in under certain conditions. So it doesn't explain how all things. There's nothing. There's a lot of materials in all kinds of like gas, liquid, and solid state that can defy magnetism, that are not influenced by magnetism. But there is no matter that is not influenced by gravity. So it's just not the same thing. It is like it. You can see like a magnet pulling on another magnet or on a metal object, and you can just see like, hey, it seems to pull towards it just like falling. But it's not like falling. Because also objects, when they get closer in closer proximity to the actual magnet, they accelerate. They go really fast. As it comes closer, it goes faster. And gravity doesn't do that. Gravity is constant everywhere, so it's not magnetism. Can't be. It's not the same nature. Hey, intensely good to have you here. I might need your wrench capabilities. People get really annoying here. It's riddled with globers in here. That's fine. I guess I invited them with the title, and it triggered them. The holy law of gravitational pull cannot be tampered with, of course, without having giant textbooks being piled upon me. Like that proves anything. Yeah, yeah, Charlie. All matter can be influenced, or most matter, by far the majority, can be influenced by electrons in them. It's called chemical reactions, but it doesn't give off the same effect, the same attracting effect, I would call it, beyond the compound itself. There's like a chemical reaction. It doesn't automatically cause like a field that pulls things towards it, really. Although some matter does attract each other. It's like the density of the matter. A liquid is often drawn towards other liquids of its type. It sticks together. That's also a force, but it's only a force that's very very short. It's only in close proximity to each other. Like if you would have two puddles of liquid next to each other in a perfect stable condition, and you would move them closer, unless they get to touch, they would not be pulled towards each other. So it's only when matter is in touch with other particulates of that matter, then it would cause to be pulled towards each other because of the organizing of the molecules. But it's not like a force that reaches beyond the matter itself, like, for example, magnetism. And gravity, neither, because gravity is just everywhere. So it's not the same thing. Yeah. Yeah, the Big Bang goes very much in the fictional region. It assumes on a lot of falsehoods, and it's just an alternative creation story based on scientism. Mm, huh. It's good to see the conversation being created in chats. Good to see. I'm looking at what you guys are writing. So, oh, Ron Burgundy, how you are wrong. There are many scientists that recognize flat Earth. They're not gonna they're not gonna be called scientists after they do that. They will be rejected. They will be smeared, and they will be ejected from the scientism community, basically. So, of course, there are many scientists out there that had at one point figured out that the Earth is flat. Especially in the early 20th century, I believe there were many flat Earth scientists, but they just got ejected. There have even been books written about this, about, well, the flat earthers know about these books, all these theories about how the Earth is flat, how that works. These are scientists. These are people that have really thought about this very carefully and that do use a lot of science in in their statements, in their model. So they're definitely scientists, but they will not be recognized by the scientific community because the scientific community has dictated through scientism that it's a globe and that all theories that prove otherwise make you stupid. So, of course, there are scientists that know about flat Earth and that believe in it and that understand it, but they're not going to be named in any science books that are going to be applied to school or anything or be recognized in the mainstream. It's not going to happen. Doesn't mean they're not there. It just means Uh, there's other factors than scientific truth. There's scientism, there's the priesthood, there's the consensus as to how things should be, and this is what we get to see. We get to see the consensus, and we basically have to figure out from scratch on our own and through the books and workings of other flat earth scientists from the past to reconstruct a more logical model based on reality on how the earth is. And this is a very complex process because it's not as obvious and as easy, especially not easy to visualize, as the globe earth, which is very just, it's a bunch of marbles, and it's all very literal in its spacing. It's all very linear and literal and physical and tangible. It's made very easy to visualize, to understand. Doesn't mean it's real. It just seems logical because it's so basic. But unfortunately, that's just not the way reality is. It's how we're being taught. It's how we're being oversimplified in our assumptions. We're being told that the world is very simplistic, very basic, very dangerous, but reality just, yeah, it's not as simple as we think it is. And well, the holographic skies are one good example of this. It's still a giant mystery to me, even that. Like, I try to give the fifth dimensional explanation because that is, I also visualized it in my vision. Doesn't automatically mean that that is really what it is, but it seems the most logical to me. It's the only explanation that I can think of or that I can imagine that proves how the holographic skies work. And they are holographic because you can't really triangulate any of the heavenly bodies. They're always on this sphere around us at the edge of our vision, and we try to triangulate. We always find out that no matter where we are on this flat earth, it's never in the exact same literal position in relation to the observer. It's always different. So that is just another one of those mysteries. It's, we don't know. And before you can actually try to find out what it is, you have to give recognition to these things. You have to give recognition to that you don't understand it, that previous assumptions were based on falsehood. It's not correct. So, any thoughts from you guys in chat? Please keep talking. I'm looking. I'm looking with you. Yeah, I know knowledge scavengers, but it was bound to happen. Like I call my hangout gravity. So there's just, as soon as you like put flat Earth and gravity in the same title, there's going to be tons of globe heads that are just jumping on it. I knew what was going to happen, but I really need your input in there. If you think they're just unbearable, please just ignore them. Just, they're just going to do what globers do: keep on repeating and just keep on sound trying to sound very small, smart, very calculating, and using peer pressure to make us try to make us feel stupid. But just don't let it get to you. It's just what they do. It's basically their own helplessness and their inability to let go of their concepts that makes them do this. It's weakness. It's a form of weakness. So just let them do what they do, and please stick with me in the subject. Yeah, I agree intensely. Uh, if they're starting to go vile, then please just remove it. I already had to remove a certain individual early on because he just kept on saying liar and all that nonsense. I'm not lying. Like, if you lie, then you're like on purpose saying things that you know are not true. And I'm trying to explain things here that I do know to be true, and I'm trying to be, how do you say that in English? I'm trying to keep in. I'm trying to keep my integrity. I know that a lot of you people will automatically and assume the global immediately say that I'm full of it and everything, but I'm trying to keep my integrity, trying to stay true to true knowledge, to what we know, what we can actually measure, and keep the assumptions out of the way because they will not help us. Assumptions based on things that are just not true or disproven, it's not helpful at all. It doesn't help us find a better answer or a better alternative. It just doesn't help. It's in the way, it's just a bunch of talk. It, it's fantasy, and it'll only cause a nuisance and agitation everywhere. It's not gonna help you either, the people that actually stick to that type of thing. So, is my sound coming through clear? By the way, I have no other way to check then except for a chat. Nim, if you can explain to me how I hold mutually contradictory beliefs, then you please explain that to me, because that's that's just ridiculous. Okay, thanks, Ian. If you can explain to me what what my contradictory beliefs are, then please tell me so, because it's just I don't see how I am really. I'd like to get an answer pretty soon now. So, because if you're just gonna make these hollow statements to try and make me look bad, I'm gonna block you. Okay? Either you're here to have an honest talk and really try to make a point based on real things. Okay, there you go. No, no, Nim, that's not contradictory at all. I accept gravity, I just don't accept gravitational pull. I say that part has been grafted onto it and it's false. A it's like a surgically added limb that's just completely useless and only there for a visual aspect. It's just wrong. Gravity is a given. It's a constant. It's a measured thing. It's repeatable in experiments, but it does not explain why, because it's not a measured force. You can't miniaturize, repeat it in anything. You can only simulate it, uh, like visually, and you can compare it to the forces of magnetism, but it's not the same. Now, yeah, you say gravity is the pull. You don't know. You call it the pull because gravitational pull calls it a pull, but you don't know what it is because it's not a measured force. It's only a given. You can only deduct it by how matter responds to the environment. It's not a force. It's not a pull. You cannot prove gravitational pull. It's just the direction that separates the dense from the less dense into one singular direction, and that is it. It's not a contradictory. It's just I'm taking gravity and taking a step back within the official theory because I say it's completely incorrect how it has been manipulated. Doesn't mean that there is no gravity. It's not proven that it's a pull or a push. It's just a constant. It's just how matter divides and at what speed, the velocity and everything. That is what is proven. Yeah, Stephen Mark Roll, if you're just gonna call us mentally ill, then there's not really anything for you here. So, bye. Ron Burgundy, that I hear Globers ask that question so many times. It's way too complicated to just give you a short answer in just because you ask that. It's, as I said before, I believe, and I base this belief on measured data, on observations made by us all and by myself, that the heavens, even including the sun, move around us, around the earth, at the edge of our vision. So that is how a sunset works. It moves to the edge of our vision. It is then set to a height that coincides with the horizon, and then it moves beyond. Doesn't mean that it's a physical object out there, it's just saying that the optics of the sun are then located in relation to the observer on the horizon. But it's not a physical object that's really there. It's just a light source. And it's not literally there. Because if you move towards it, then it changes. It changes its position. It moves away or it moves further up. But the Earth is flat, there's no curvature, so it doesn't move around the Earth. It just moves out of sight. Because when you go north and south, and usually the sun, well, always actually, the sun is at some kind of southern point. If you move from equator to anti-equator, it's like go to the north or to the south, this changes the angle of the cosmos globe, of the heavenly bodies, the globe of the heavenly bodies that move around us. It changes its angle. So that has all kinds of changing effects, but you never get to approach it. It always stays somewhere on the edge of your vision. You never get closer ever. And that's just what we've observed. That's just how it works. And that's why I say it's holographic. And when I say the heavens are holographic, it doesn't mean that it's like some computer simulation or anything. It just means that it's showing the properties of typical light non-literal position. It's like an optics. It's like an optical trick. It appears to be there like an illusion, or well, like a hologram. That's why it's holographic, but it's not literally there. It's just reflected somehow, or that's how we can simulate it. It's reflected somehow to be visible to us at that point. Doesn't mean it's a physical object that's over there. It's just holographic. Where it's reflected from, how that works, I don't know. Although I am currently under the assumption that's actually from the fifth dimension, from a dimension above us where it is literal, where they do have literal positions. But that's still an assumption. It's very hard to prove this kind of thing. Like over-dimensional things are very hard to prove anyhow. But it's the closest I can get. Hey, Mayaka's place. Nice to see you here. Yeah, I'm doing great. I've uh, I've actually met some really interesting Spanish people. Uh, just a few days ago, I just bumped into them, and they were amazing. Like these really young kids, and they were really like the Veni Vidi Vici type. And they felt so good and so self-confident and so open-minded that I actually told them about flat Earth, and that was, yeah, they they responded in a way that I didn't expect, because I thought like, oh yeah, I'm gonna get it now probably, but they were very open. They tried to visualize as I was explaining, and they were just like, whoa, that's amazing. I never knew that. And I think they're not gonna get caught on it because they are people that are really veni vidi vici. They take the ignorance is bliss concept and they made it their own, and they were just very blissful, joyous people with a lot of vibrant energy for life. They were great. It was like I felt such a contrast with myself because I'm always in my mind trying to figure out big stuff and like worrying about things, and these people were just without a worry. They were glorious. They were glorious people, and I really hope to talk to them again. This really nice girl as well. So anyway, yeah, so sometimes people don't get angry, they don't get sad when you talk about flat earth, although they did mention that they had seen and heard it about it before, just like a conspiracy theory, I guess. No, Brenda, I'm not going to invite you on my show. I know how you are. I it will be cool to debate with you like somewhere else maybe, but no, I'm not gonna let any globers like on the show and show everyone how you're so much better at math and how you studied all the textbooks so much better. Because I know you do. I know you all studied it very, very well. You know it all, but doesn't make it real. It just it's just a doctrine. So so the weather has been slightly better here in the Netherlands. It was quite rainy at times, but now it's just it's warm again. A bit cloudy. It's nice. No more big storms. But it's okay. I can't complain. It's a good late summer. So uh, is there anything more I need to explain? Is there anything like that you would read in the description and that would bring about questions that you want me to answer directly? Just tell me. I did actually explain the sunset, Ron Burgundy. I did exactly that. So I don't know why you keep saying that, but you said that before. You asked the question, I answered it. Pay attention, okay? Yes, I did. I explained exactly what that is. So I'm gonna. Yeah, sorry, but that it is what I said was an explanation. I told you about the holographic bodies, how they're always on the edge of your vision, and that is what we get to see. We get to see how the sun is not a literal physical object and it just goes down because it moves like all of the heavens as a sphere around us. What's only optical. It's not physical objects out there. It's an optical thing that's always on the edge of a vision, like a hologram, and it just moves with you. And the sunset is just a part. It's basically an orbit on the globe that surrounds us. It has a certain path, and astrology has lined out these paths of the sun and the moon and the stars perfectly, and that's what it is. It's not physical objects out there. It's just a globe of the heavens, an optical globe at the edge of our vision, and it always moves around us. And that is the explanation. That is just what it is. I don't see what your statement has to do with anything, Ron Burgundy. Holograms do not debunk geometry. No, they don't. What does that have to do with anything, really? Like, what has geometry even to do with the sunset and everything? I don't get it. I don't understand your train of thought there. It's just yeah. Okay, good. So, anybody else wants to actually do like a real conversation, a real discussion, and not just like saying annoying, stupid stuff all the time? That exactly. Thank you. Yeah. I really hope that it wouldn't come to this. That like when all of these globers came in at first, I kind of hoped that you guys would just keep your cool and just really try to listen. But it's like you're not hearing me at all. You're just sticking to like, does what I say make any sense on your globe model? And that's just it. That's the only thing you seem to be listening for, because you're not you're not responding to anything I say. It's like every time I explain something, you just say another question that has absolutely nothing to do with what I explained. So you're not giving me any sense that you're even listening to what I'm saying. You're just spamming. You're just getting in the way. So I'm getting you out of the way. And that's why I've been blocking a whole bunch of you right now. And too bad. I had hoped that you would actually, yeah, well, could have the composure to actually get something good out of this, but apparently not. So it's too bad. Ooh, yeah, gonna do it a whole lot more. But that's fine. If you want to go into endless debates and like really grind it away or anything, just go to Dread's hangout or something. You've been exposed. Like he likes to draw on the globers and then get into these endless debates with them and pretty much show everyone what kind of a fool you are in your whole logical way of reasoning things and doing everything that you do. So that's a good one, Dan. Troll Team 6. Yeah, they seem to have been here, but I think I pretty much ejected most of them. Oh, God. Yeah. So, gravity. Yeah, there's a distinction between up and down, and that's thanks to gravity, basically, and that's it. And things have a constant falling speed because of gravity. But other than that, we don't know what actually causes this. It's just a measured, it's a constant, it's something that we deducted from how objects and matter respond within this environment that we live in. But we can't really measure it other than by deducting information from objects, how they respond in the environment. That's the only way we can deduce gravity from. And that's just it. But it's still there. Just it's just another mystery. What causes it? And well, we can like theorize about this a lot, but When it comes to actual experimentation, it's going to be a lot more difficult. Because how would you emulate a constant field of gravity other than the one that we already know? They often say, yeah, you can't escape gravity. What comes up goes down, and this is just true. We haven't found a way yet to neutralize the effects of gravity. We can counter it basically by having other forces grab hold or pushing away, that kind of thing. But there's nothing that really cancels out gravity. There's no like box that we can make in which somehow objects would just free float like there was nothing, as if it was like flying down and going with gravity at this the speed, the speed going down, and that would cancel gravity because of the motion. But other than that, in a stationary setting, there is no way we know to counter gravity. There's just no way we do. And that's just it. Just keep on coming, guys. Now, I don't believe in the Cavendish experiment. I told you it's a very kooky setting. It's not very reliable. It's very slow, very easy to tamper with. It's non-reliable. It's not a very reliable method. And the Cavendish experiment could probably be done in a more reliable setting, but that would simply disprove that it actually works like that. You just take stone objects instead of iron objects or any kind of metal and do it with that and keep a constant video stream on it uninterrupted, just constant, not a time lapse video, then, well, that would be interesting to see, but I really doubt there's any effect because outside of magnetic influences, there's nothing really that can pull things towards each other like gravity does. Well, or that could emulate the same effects that would appear to be gravity. Other than magnetism, it's not out there. We don't know how to do this. So I do believe in experiments. I just don't believe in crappy setups and very easily fraudable experiments that are a result of the whole scientism era where people love steampunk contraptions, look very interesting, look very mechanical, that would so-called prove all these fake sciences. But that's just what they are. They're just steampunk contraptions. It's like an art. Scientism basically uses art and imagination to suggest science in many cases. Not in all cases, because in between there is real science here and there, just the measurable things, but the conclusions are often bridged, glued together with these weird, kooky contraptions that just make no damn sense, that don't work out. They only work out in theory or they're tampered with, and it's just not going to happen. Okay, paper explanation. Do you believe gravimeters work? I, I have no idea what that is really. What is a gravimeter? I would like to know that. Sounds really silly. It's probably not for measuring gravity. Yeah, that's fine. Ah, wait, I get it. A gravimeter is probably a device that measures the relative strength or the fall, a relative falling pull or speed on objects, like as you move. So as you would like go down in an airplane, then part of this gravity would be negated. Well, of this apparent gravity would be negated because of the movement motions, because of the motion you're making, and that would give you a different relative gravity, right? Is that what it does? Because that makes sense. It still doesn't prove any force. It just proves that if you move with the direction that gravity is set at, then you will appear to counter this this movement force, or this thing that causes well, heavy matter to divide from lighter matter into a specific direction. You will counter this motion, this constant. That is probably what a gravimeter does, right? Okay, now that just sounds silly. Gravitational profile. That's probably based on gravitational pull physics, right? That uh, how much relative gravitational pull would a certain combination of objects have towards the center of the Earth, right? But that's just bogus. It's just scientism gymnastics. It's just a toy. It doesn't do anything. Mhm. Ah, yeah, Dan Winfield. Yeah, you mentioned that certain insects have hard shells to protect their internal organs from gravity. Well, in a sense, it's not as much gravity as most insects have like very fluid internal organs. So what they use the shell for basically is to contain it all. Because if it would be open, then it would be more subjected to forces, all forces, movement forces, or like anything that would try to penetrate it. So it needs the shell to basically keep it in its place. It's not, yeah, it's not gravity as a force. It's just, it's more a buoyancy thing. It's just, it needs to be contained in the location, because otherwise it would, because it's mostly liquid, it would tend to move in all kinds of directions and wouldn't function the way it was designed for the creature to survive with. So in a sense, you could say that gravity has but that's the whole thing with gravity. It's because gravity can be deduced from the properties of matter in, well, almost absolutely everything. You could just say it's gravity, but that doesn't make it a force. While when we talk about things and we say gravity does it, we imagine it automatically because of all the conditioning, because otherwise it's very hard to grasp. We imagine it to be a force, like it's a literal, an energy thing, something that does that. But that's not what it is, because we can't measure it. We can only deduce it from other matter. So it's more like a constant in the properties, or well, that are applied to the properties of all matter. So I guess that with the insect, it would be more like a buoyancy thing, because it's liquid. It will tend to spread out because of gravity, because it will be pulled more easily. It's not as cohesive. It will be pulled out of its place more easily, so it needs a hard shell to keep it in its place. Basically, that's it. Hey, Jonathan Doherty. Huh. Yeah, I see. Yeah, that's exactly what I thought, Jonathan Doherty. Thank you for posting that. I think I explained it like that. It's just a gravimeter is an instrument that is used to measure the relative gravity in emotion situations, to see what the relative gravity is because of the motion, because motion downwards cancels out gravity. It's basically what gravity does. So if it moves it with it towards that one direction down, then you cancel out the, well, the effect that causes objects to fall down. So you neutralize that. So the relative gravity would become zero in a free fall within within an item, within an object. It would be moving with the gravity constant perfectly. So in relation on that object, there would be no gravity and things would start to suspend. So I guess I was right in what a gravimeter does. My assumptions in that. Yeah, thanks for coming, Jonathan Doherty. Always of Doherty, sorry. Good to have you in here. And yeah, I started this hangout because I just thought, yeah, I have to do this. I know it's kind of annoying even, like, because so many people are responding to this in a negative way, in a ridiculing way, but it just has to be done. We have to really get honest in what gravity really is, what we know it to be, and what its properties are in reality. And be honest about it, no matter how complicated it gets, no matter how hard it makes to actually visualize what it really is, and not start jumping to conclusions just to make it easier for yourself or to back up your grand cosmogony idea. Because if you don't apply it correctly, then you're using a foundation stone that's just wrong. It's just completely wrong, and it wouldn't work out. It just appears to work out because you're overlooking how it's not really working out. And that's not how you come to real truth, to real measurable, repeatable truth. You have to be honest about what things are, even if it's inconvenient. No, no, Charlie, that's not true. The Earth's gravity is constant. It's constant everywhere, on every altitude and every location. It's absolute falsehood that you would claim such a thing that it's not, because it's constant everywhere. No matter how high up you go, things may accelerate to their maximum falling speed a lot faster because the air is a lot thinner over there. So there's not as much air friction to hold back the acceleration to full falling speed. But the falling speed is always constant. Just like in a vacuum, it always moves at this maximum speed of 9.8 meters a second. That's the maximum speed things fall. It's just the way it works. And it's the same everywhere. To just claim that it's different at different locations, that's just a complete falsehood. That's a false claim. It's not true. No, it's not. Paper explanation: a gravimeter does not prove me wrong. Gravimeter is simply a device that measures the relative gravity in a moving object. So if you go downwards, then the relative gravity on that ship, let's just call it a ship or a craft, would be less, would be cancelled out because of the downward motion. Doesn't mean that it proves me wrong. It just says that if you the relative gravity, if you're falling, then it will be cancelled out as soon as you hit that maximum speed. And if you hit less than the maximum speed, you still glide somewhat, using the air pressure to create a counter lift, then there would be not the full gravity, but just a little bit. So that's just how it works. Yes, exactly, Ian. That's exactly what it is. Yes, paper explanation. I wasn't sure what it was, but it just explained to me, and I guess that in my assumptions, as I thought that it would probably be, I was right. So that's just it. So now I know. Hmm, gravitational acceleration. No, my God, dude, that's not a thing. It just different gravitational accelerations. No, the gravitational acceleration is everywhere the same. But if you measure the relative gravity on an object that is falling, or on a device that is partially floating, like an airplane, then it would show the relative gravity. Doesn't mean there's different gravitational accelerations, because there is no location anywhere where things would fall faster. Just doesn't happen, except for a vacuum, and then even there's just this maximum uh, falling speed. That's just the way it is. There is no variation in gravitational acceleration anywhere. There's not. So, okay, that is surprising. That if that is true, Jonathan Doherty, then that's the first I've heard of that. Seems to be very tiny difference though. I wonder how they measured it. Did they? How would that work? Well, it is very interesting concept. I just wonder who actually did that, who did that experiment. And well, when I look at the numbers there, they seem to be almost insignificant. It's like a very minute detail. So I wonder how large the experiment was, how extensive. Because, and very important is the relative air pressure in that region, in the region where they did the experiment. Because if you do an experiment with gravity in a region where during the entire fall the air density is a lot less, then things will definitely fall a lot faster. They will accelerate faster because there's less air friction. Doesn't mean that, like, they would have to actually test an object falling in a vacuum on that location, and then for things falling in a vacuum on another location. And that would definitely prove if there is a difference in gravitational pull, or look who's talking here, in gravity. And there is no gravitational pull. So that would be very interesting to see. And I kind of doubt that they did that, because they usually just tend to measure things in the open air. because it gives variation and that's more convenient. And they just hope that people will overlook that bit of variation in there. So why why would a gravimeter have to be housed in a perfect vacuum? That is ridiculous. That is absolutely ridiculous. What does that have to do with anything? Now I'm talking about objects falling within a vacuum and then measure the the speed that they did fell in relation to the distance. There's no real other way to measure it. You don't even have to use a very special device for that, although I guess in through other methods you could, yeah, like a gravimeter, you could probably design, yeah, like I said, make a device that measures the relative gravity, but it would probably just use some kind of very stable buoyancy mechanic to make that out, the difference. Yeah, so I think you're not a very reliable person here, so I'm just gonna get you out of here as well. You're not here to actually have a discussion. Yeah. Uh, yes, Charlie, that's exactly what I said. Only for absolute measurements of the value of gravity do they use a falling mass just done in a vacuum. That is how it is done. That is how you get the definitive gravity. Like, that's the only way to really figure it out. So, if there would be locations on the Earth where this gravity constant would differ, then you would be quick to notice by having to, on these two locations, have objects fall within a vacuum and just see if they arrive down at different times. And that would be very measurable, very easily measurable and repeatable. So, unless it was done in that exact setting, I really doubt that there has been a real experiment that proves that the gravity is different in different locations on this world. I haven't seen any definitive experiments that would prove that. Yeah, you got a good point there, Charlie. Not all instruments actually do use uh, the vacuum dropping objects experiment to measure uh, the relative gravity, but that's because gravity is applied to all objects. Basically, it's applied to all matter, and you don't always need to do that exact experiment to isolate uh, gravity effects, the influences of gravity. You can basically use buoyancy, like the pressure from buoyancy. When you fall, then the pressure from buoyancy changes in relation, like we've even seen in the NASA fake diving plane footage. Like if you put water in a zero gravity environment, in a perfectly falling environment, it would start to, yeah, become a globular. it would expand in all directions. But if it was less, it would flatten out or fall down slowly, perhaps. So if you can use this concept inside of a device, then you can use the properties of buoyancy to basically get a measure on what the gravity is likely to be. But it's basically measuring falling speed. And then based on that falling speed and the properties that it bestows upon the object that is measured, and then you can draw a conclusion from that what the relative gravity should be. So you don't always need to do the perfect isolated falling objects in a vacuum experiment to do gravity measurements, but to absolutely isolate all the effects, like if it's not falling, if it's not air resistant, all that stuff, the only way you can truly isolate the properties of gravity is by doing the vacuum falling experiment. So, but you can always, measure relative gravity, well, using buoyancy in a device. So that doesn't surprise me at all. Yeah, I know, Jonathan. Gravity is interesting. It's very bizarre. It's, as I said, it's a very mysterious. To call it a force is technically wrong. It's a very mysterious constant, a very mysterious thing that cannot be directly measured, like magnetism, electricity, or anything of that. It can only be deducted from how matter responds to the environment through buoyancy, basically. And it's very widely applied to everything. So there's always some kind of influence of gravity on things, but gravity in itself is not measurable, not really. You can only measure gravity by deducing aspects of physical objects, and then through that deduction determine what the gravity constants are. And that is what gravity is to us. That's the only thing it really is to us, because it doesn't have any directly measurable force that causes it, and it's equal everywhere as far as we know. Uh, Although are suggestions done that gravity might be different in different locations, but I somehow doubt that. It would be interesting to actually do, what I said, a vacuum falling experiment in these locations to determine if there really is a difference in gravity, or it was just another scam by a bunch of scientists and people that wanted to just inject the idea that the gravity could be different to back up basically the concept of space and everything. So, because that's done a lot, there are a lot of scientists and people out there that just falsify these experiments, probably in order of the government or whatever, the scientific community, council or whatever, to propagate the globe, to do that. I'm absolutely certain there's a lot of fraud out there, and has been for a long time. It's fairly easy overseen. So as long as the scientists that perform these things are not shamed directly, are still respected in the community, then everything's all right to them and they're okay with doing that. And they often believe it themselves, but it's it's like a trap door double. Like they believe it, so they do it and they assume that they're right, but they're overlooking that it's not actually real, that they are basing their assumptions on beliefs. So they're basically scientists and people that believe they are scientific, but they're actually assuming a lot of things that are not absolutely proven, that are not really true. And that way there should be, the world's probably filled up with all kinds of experiments that are just wrong, or even been tampered with. No, A4, I didn't get outcasted by you and exposed. And I don't think he called me a troll. I'm just uh Dread has like his own style, and he's always like dissing on Isherlot. He's always dissing on NASA, and he's often like pulling in Globers and then ridiculing them. And well, especially lately, I've just not been very much in the mood of to doing that kind of thing. So it's like there is some negativity involved, and I guess that especially NASA does deserve this, of course. But I'm not really attracted to that at this time. Like I may definitely return, and I really like the way that he built his channel. It's really cool, and I like the panels and everything. It's a really fluid debating group, and I like that. But yeah, I don't feel the need to come on there right now. So that's why I haven't been there for a while. But I still support what he does. He's great getting people together. It's almost like a bit of a like he's like a flat Earth carnivore ride, like really flashy sounds and visuals, and just having fun, being with the guys, and and that is really appealing. It's like really cool to have like this carnival attraction. You get on the flat Earth panel and you go and you talk about you get confronted with NASA stuff and you laugh about it and you go into debates with Globers, and it's really funny. But yeah, currently now I'm for the moment I'm just not much into that thing right now. I'd rather fix myself on really the hard to grasp ideas and trying to prove well the flat Earth rectangular looping model and help people to visualize this better because it's still a big problem. It's like to me it's really easy to imagine like how this would work at least on the in the 3D level. I have a very clear view on how this works. It's not hard for me. It has been there in my vision for a long time also. But a lot of other people just when they hear me talking about this, I guess that they're like for a moment like into it, so they kind of get it. But still, there are so many different factors, and it's also non-linear, non-physically literal, and everything, and that makes it a lot harder to really grab through it. It becomes surreal, and I guess the Earth is surreal in many aspects, and I want to help people overcome that part to really grasp better how these complicated factors work because it's just very hard to understand this, to really get into it and to get it. And you're not stupid if you don't get it, because even yeah, it'd be hard for anyone pretty much because well, surrealism is generally very difficult to see through, to understand. That's just the way it works, and the Earth is surreal in many ways. So that almost automatically dissuades many people from looking into it. It is basically what the scientism guild has been running on. They're just saying, no, look, it's just a globe. It's very simple. It's like this, and this. We got it all calculated out. It's all set. You just have to overlook all the things that are inconsistent, that don't line up with your observation. Just go with us, and that's fine. You don't have to worry about it anymore. And it works because, well, people that actually do start figuring it out, and this should have been a lot harder along, like, say, for example, 50 years ago when there was no internet community and everything. You couldn't just watch all these videos that explain it to you. It's a lot harder. It gives you a headache to actually find out how complicated things are. And that the further you go, the more complicated things get because it becomes harder to figure out, and it becomes harder to accept for those that are not into it. It becomes harder to understand. And this is even why I think many more prominent flat earthers out there have, for example, chosen to discard the rectangular looping model despite so much evidence that supports that that's probably a more realistic model because it is harder to grasp and it goes too deep, as it were. It It goes a little bit too deep, and most people that are just touching upon that the globe might not be real, that the Earth is flat, might be flat, that are considering it, it's just too much for them. So they just step away and they say, no, this is too much. This is just going way crazy. This is like these guys have been smoking all this hallucinogenic stuff, and now they think it's like this, and it's completely crazy. That is what I would think if I really believed in the globe, and I would be confronted with this kind of thing first, because it is so surreal. How can it be real? See, that is just the way the mind works. We want to simplify things, and it is not simple. And that is what NASA thrives on. It thrives on people's need to keep things simple. And their globe model, despite being absolutely incorrect in so many aspects, is very simple. And that's why it works. That's just it. And it's going to be a difficult task to get people to really figure out how it actually works. And well, we're probably going to need the circle-centric classic flat Earth enclosed model with the literal sun and moon over the equator. We're going to need that model for a while, just as a study aid, just to get closer to the real complex reality. So I don't blame people that stick to that at all. I just say, like, stay respectful, realize what you're doing. You're basically choosing it's a political decision to keep things a little bit more simple, to keep drawing in that audience, and to keep them stuck to you, and not get too many people that will just walk away outright because they think, no, this is too much. So understand, it should be there, but we there should be plenty of people that will probably still get this, or at least try to get this, that are willing to embrace the real surreal complex reality of our looping rectangular flat Earth, and that will be willing to go along with us and help figure out more and help visualize it. And I think, yeah, everybody just does what they do. NASA will keep doing their crazy globe stuff and their space experiments and all their magician's trick to mesmer the masses, and then the flat Earth, the base flat Earth base, will keep on using the circle-centric model and show people where NASA is just absolutely wrong. Just prove it to those who are willing to step away from the globe. And then when these people are sufficiently educated about these, then they will eventually start to see the flaws and realize, wait, this is not entirely correct either. But you can't really go back when you go flat, because you've already seen in how many ways the globe is so wrong, undeniably wrong. Once you actually get it, once you embrace this, there's no way back. And then, well, there's alternatives, and there is, well, my model and other people's model that might vary slightly, or there will probably be a division eventually for a long time to come, in if people believe that there are lands beyond the North Pole and the South Pole, and it's still a possibility. Definitely in a rectangular looping model, there's this possibility. It loops from east to west, but what's in the north and the south, yeah, it could also go on. There could be more land out there, more layers, and theoretically, if this continues on, it could even be looping, or there could be like a dead center at the north and a dead center or a dead edge at the south at some point. Who knows? We can only figure this out once we actually go there and then determine if there are more lands or if there is an edge to the dome. And before that time, it's going to stay purely theoretical, and there are going to be arguments like, yeah, there's land beyond, or there's not land beyond. But there's still a lot to work with. You can still figure out how these amazing holographic skies work. That's something that the circle-centric flat earthers really don't do, because they still assume, they base their assumptions of what the moon and the stars and the sun are based on an idea that the sun is in a literal position from a certain distance and all that stuff, and they just disregard that it's not really triangulatable, that there's no fixed position. It's only a position in relation to the location as to the angle of the heavenly bodies, and the visual aspect of the person where they're standing on the edge of their vision. So that's it. And it's going to be like that for a while. And there's going to be plenty to talk about for everybody, and plenty to play with, like Legos. You're going to keep building the blocks and like seeing, wait, this doesn't fit. It does fit on that one, but we know that that one has a faulty foundation. So what are you going to do next? It's just like a giant puzzle, a Legos puzzle, figuring out what this reality really is. But within all these arguments and these debates, uh, people will try to find shortcuts to overcome psychological elements, psychological friction. So that's why I think that many especially circle-centric flat earthers, have started to say like gravity doesn't exist; it's only buoyancy. But this is just a shortcut to get that argument out of the way, to stop talking about the really weird, complex thing that is gravity, because it's headbreaking. You really have to be into it to get it. You have to hear me talk for over an hour about this stuff, and then you'll probably understand it too. If I make any kind of sense to you anyway. And yeah, they basically devised this concept that buoyancy replaces gravity, and you don't need to think about it anymore. It's just down and it's up. And in a way, I guess it is correct, but still there are these measured factors of gravity that make it a constant. And that's also a thing. It's also a thing widely applied in physical science, and it should not be completely dismissed. It's still there. It's just not a measurable force except by how matter reacts in the environment by falling in a certain direction or by floating in the other direction. And that's just it. And that is, yeah, that's the way it's going to be. So anyway, I've been talking for quite some time now. uh, I think I basically explained everything I wanted for like 3 times over now. We did get to answer some questions in chat. Thank you all for coming, and yeah, I hope I helped you get get these details straight about gravity. Gravity exists. Gravitational pull does not. And yeah, good luck proving that. The Cavendish experiment's complete rubbish, and I've already suggested the alternative experiment, what you could do, but yeah, nobody ever does that, it seems. So, well, apparently it doesn't work in the advantage of blowers. Otherwise, they would have grabbed onto it by now, latched onto it, and used it to shove in our faces. So, I'm assuming currently that it actually disproves gravitational pull, the experiment. So, for now, I want to thank you all so again for watching, and keep it flat, and I'll see you guys next time. See you all.